A deer steps into a clearing on Komodo Island. It doesn't hear anything. It doesn't smell anything. But something is already watching. A 3-meter predator, nearly 80 kilograms, lying completely still in the grass. It has been waiting for hours. The deer takes 2 more steps. Then the dragon moves. The attack lasts less than a second. The deer breaks free, bleeding. It runs. And here is where it gets strange. The dragon doesn't chase. It just watches. For decades, scientists said the dragon was simply waiting for bacteria in its saliva to kill the prey through infection. Dirty mouth. Passive death. Case closed. Except that explanation was completely wrong. New research has dismantled that theory entirely. This animal isn't waiting for germs to do the work. It is actively injecting a venom system so precisely engineered it targets one specific biological function and shuts it down. The Komodo dragon is the largest living lizard on Earth. Adults reach up to 3 meters in length. They weigh up to 90 kilograms. They can sprint at 20 kilometers per hour in short bursts. Their claws are curved like hooks. Their serrated teeth cut through muscle and tendon simultaneously. But none of that is the most disturbing part. For most of the 20th century, researchers observed that prey bitten by Komodo dragons died slowly, even when the wound itself seemed survivable. Scientists assumed bacteria in the dragon's mouth were the culprits. The dragon eats rotting meat. It never brushes its teeth. Its mouth hosts dozens of bacterial strains. The logic seemed airtight. It wasn't. In 2009, University of Melbourne researcher Brian Fry and his team scanned Komodo dragon skulls using MRI technology. They found venom glands. 2 of them. 1 on each side of the lower jaw. Sitting between the teeth, tucked inside the gum tissue. These glands produce a complex venom cocktail containing anticoagulants and compounds that cause acute hypotension, a rapid, catastrophic drop in blood pressure. When the dragon bites, the serrated teeth don't just cut. They create channels. The venom flows directly into the wound through capillary action. The prey's blood stops clotting. Its blood pressure collapses. Its muscles weaken. It loses the ability to stand. The dragon didn't evolve dirty teeth. It evolved a pharmaceutical weapon. The bacteria were a coincidence. The venom is the design. That single realization changed everything scientists thought they knew about monitor lizards and reopened questions about reptile evolution that had been considered settled. Put yourself on Komodo Island. You're hiking. Dense scrub on both sides of a narrow trail. Temperature is 35 degrees Celsius. Humidity near 90%. The dragon is roughly the size of a full-grown crocodile, but it moves differently. Low to the ground. Silent. You don't see it until it's 4 meters away. At that distance, it can close the gap before you finish your first step backward. Its jaw opens. You have no way of knowing, in that moment, that what's inside is not just teeth but an active venom delivery system. One clean bite to your lower leg, and the process begins. Anticoagulants enter your bloodstream. Your blood thins immediately. The wound doesn't clot. Within minutes, blood pressure begins to drop. Not slowly. Sharply. Your body is fighting blood loss and vascular collapse at the same time. Here is what makes this stranger. Komodo dragons also reproduce without males. Females in captivity have produced viable eggs through parthenogenesis, the ability to fertilize their own eggs. Offspring produced this way are always male. Scientists believe this mechanism may allow a single female to colonize a new island and establish an entire population from scratch. This is not a quirk. This is a survival architecture. The venom system, the ambush behavior, the reproductive flexibility, none of these traits evolved in isolation. The Komodo dragon has been refining its biology for approximately 4 million years. Its closest relatives include other large monitor lizards, and Brian Fry's research suggested that venom glands may be far more widespread across lizard species than previously recognized. The Komodo may not be an anomaly. It may be the most visible example of a trait hiding across an entire order of reptiles. The bacteria myth persisted for nearly 100 years. Not because scientists weren't looking, but because the answer seemed obvious. Dirty animal. Slow death. Done. Science sometimes moves exactly that way, confidently in the wrong direction until technology forces a correction. MRI scans of a lizard skull changed the story entirely. The Komodo dragon didn't change. We changed our ability to see it clearly. And that gap between what we assume about a predator and what is actually true is where the danger lives. Humans have always categorized animals by what we can observe on the surface. Teeth. Claws. Speed. We built safety assumptions around those categories. The Komodo dragon survived for 4 million years by operating beneath that surface. Venom tucked inside gum tissue. Strikes calculated to maximize hemorrhage. We are still rewriting what we know about apex predators. New research, new technology, new corrections. Subscribe to Humans vs. Species, because the most dangerous animals are the ones we think we've already figured out.